once around Triton. So Triton is a moon of Neptune. It's the largest moon of Neptune, and it's largest by a very large amount. It represents 99.5% of all of the mass that is in orbit around that giant planet. The pie chart under the text there, blue is the mass of Triton, and the orangey red bit is everything else in that pie chart. All 15 of the other smaller moons, the rings, everything that we know about. So it's by far the dominant object in orbit around Neptune. Discovered in 1846, October the 10th, by William Lassell, English astronomer, using his homemade 24-inch reflector. This was very much a thing back in the day that English gentlemen would make themselves a telescope and get involved in astronomy. Now, William Lassell did not suggest a name for this object. It was just referred to for many years as the satellite of Neptune. But in 1880, Camille Flammarion suggested the name Triton in his book, Astronomie Populaire. He was French. And this name comes from the Greek sea god, the son of Poseidon. And of course, Poseidon is the Greek god corresponding to the Roman Neptune. So that made a lot of sense. But it was a couple of decades before it was officially adopted. So a very long time without a name. But I think Triton is an excellent choice. So it orbits almost circularly around Neptune, but at a very large tilt. And that's interesting. It's not only tilted relative to the equator of Neptune, but it's also tilted relative to Neptune's path around the sun at quite a high angle. But the weirdest thing is that it's going backwards. It's in a retrograde orbit. So it is going against the rotation of the main planet itself. And that is common for outer tiny moonlets of the giant planets that have been captured as captured asteroids, etc., and completely against the direction that you would normally get with things like our own moon and the main moons of the other planets. So it's very, very curious indeed that it's in this weird orbit. It's also tidally locked. It's got, just like the Earth-Moon system, one face of Triton points at Neptune all the time in order that this minimizes the tidal effects of Neptune on Triton itself. That tends to stabilize quite rapidly when you have a reasonably close orbit. So physically, it's the 7th largest moon in the solar system and the 2nd largest in relation to its primary. That gives it a diameter of 2,710 kilometers. So that's quite a big object. Massive enough to pull itself into a round shape and with enough gravity to hang on to an atmosphere. In terms of composition, it's a lightweight. Its density is only just over 2 grams per cubic centimetre. And this suggests it's made of ices, things like water, ammonia, methane, and any amount of the heavier elements must be in quite short supply. We think it's somewhere between 30 and 45% of the total mass is water ice, and there will be other volatile compounds such as ammonia and methane that have frozen out onto it as well, even carbon monoxide, things like that. Kept warm in the center by radioactive decay of isotopes and by the obliquity tides due to its orbital tilt. Because it's orbiting at this tilted angle relative to Neptune, and because Neptune is not a perfect sphere, the rotational bulges at the equator of Neptune are going to pull and put on the different parts of Triton in a manner that is going to stretch it and squeeze it as it moves around this tilted orbit. and that flexing internally is going to create frictional heating and keep it a little bit warm. We do think that's going to find that there's a rocky metal core deep inside. We think most objects probably have that. The heavier elements, the denser elements, tend to sink towards the center during a phase when the object is still molten and everything can move very easily until it begins to cool down. So the surface, well, if we look at it, we've got this one photograph taken by Voyager 2, and it shows a varied terrain. We have the top region, which seems to be covered in some interesting grooves and looks like the surface of a cantaloupe. And then down at the bottom, we have this sort of pink snow, which is made of frozen nitrogen, methane, carbon monoxide, and again, those complex tholins. The tholins being the carbon, hydrogen, nitrogen, oxygen compounds created by strange chemical reactions where the solar wind impacts the material and knocks electrons off it and activates it to undergo all these weird and wonderful chemical reactions, building complex molecules. We see changes over the time since we've been observing it. We can now look at it with things like the James Webb Space Telescope and indeed Hubble before it and get a reasonable view, not quite as good as Voyager. Standing so far away from it, it's very difficult. And we can see that things have changed since Voyager was there, and this looks like seasonal variations. Again, because of that tilt of Triton's orbit compared to the direction of the rotation around the sun of Neptune being so extreme, it tends to point one hemisphere more towards the sun than the other as Neptune moves around in its 165-year orbit of the sun. And the other thing that this image doesn't show is any impact craters. It's just completely devoid of them. There are very, very few over the surface. You can, if you look really hard, maybe make out one or two small impact craters, although it's not clear that there are very many at all. So this means that the surface is young. This is a high resolution picture, and there is an impact crater or two, small ones in this image, but not very many. And we think that the surface has an average age less than 100 million years. That's quite a short time period compared to the 4.6 billion years that the solar system has been around. So the turnover here is fairly rapid, and as soon as an impact crater gets made, there is a probability that it will get erased again by being buried by new material that is being brought to the surface and redeposited. And up there in the top left-hand corner, where the call out is pointing to a very smooth region, there's one impact crater in the middle of the picture there, one up in that area. This is a cryolava lake. Cryolava is low temperature lava, so this is actually things like water and liquid nitrogen and other chemicals that we normally think of as either liquids or gases, but at these very low temperatures, minus 230 degrees centigrade, they can take the place of lava in terms of earthly volcanoes. You can get eruptions that pour the material out, which then freezes on the surface, and that's what we think has happened in that large smooth area. And then a small asteroid has come along and punched a hole in it afterwards. And of course, we see small craters and not large ones because large ones are rare, and so you don't get very many of them in 100 million years, and so the chances are that all the large ones have been rubbed out. But there's certainly fascinating detail in the photograph there. And then we have this region, the snowy region down at the bottom of the main image, and this shows all these dark streaks. And these dark streaks are these cryovolcanoes. They're geysers of liquid nitrogen erupting up out of the surface and then material carried up by the geyser is being blown downwind. You can see they're all pointing one way on this image. These are all fresh deposits of this dark ejecta that's been brought up with the liquid nitrogen and deposited downrange. And we think that black material, that's got organic compounds in it. And again, this points to something that's creating this material deep underground, perhaps in layers of water trapped beneath this crust. And maybe it's warm enough in the interior for liquid water to exist. And maybe this is some sort of biochemical process, a living system that is creating this organic material. And then the heat is bringing it to the surface and depositing it in these black streaks. We don't know. It's pure speculation at this point, but it's really telling us that we need to go and explore these worlds in much greater detail than just one flyby. I said the geysers are going downwind. Well, that requires an atmosphere, and there is a thin layer of nitrogen, a little bit of methane, a little bit of carbon monoxide. There are clouds of nitrogen ice crystals, and if you look at this image back across the limb of the moon there, we can see a cloud in the atmosphere of Triton. There's also a haze layer. Again, this is organic material, hydrocarbons and nitriles. In other words, some of the precursors of tholins again. And so these are being created by the photochemical reactions of sunlight on methane and also of charged particles. And again, we're detecting the seasonality in the atmosphere. Over the last 30 years of study, we have seen that the atmospheric pressure has changed by a factor of 3 due to more volatile material, perhaps as Triton has been warming up as the seasons on it change. And so everything about Triton, its size, its mass, and its composition, very similar to both Pluto and Eris in the outer parts of the solar system. And this really suggests that maybe Triton shared an origin with them, either being formed roughly in the same region out of the same types of chemicals and material that was out there, or even formed together with them in some more complex arrangement. And we know that it cannot have formed along with Neptune. This retrograde orbit is just not right. All the inner moons that you see on that diagram are all going the other way. They are prograde. They are going with the direction of the spiraling of material that would have formed Neptune and all those little moons at roughly the same time. Even the newly discovered one marked in orange there, S2004N1, doesn't even have a name yet, is going the same way. And in fact, all the moons interior to Triton go the same way. Triton goes the other way, and in fact, beyond Triton, there are some more moons, some of which go the correct way round and some are going backwards. And this all looks like Triton having been captured from the Kuiper belt. It may well explain the rather eccentric orbit of the second largest moon of Neptune, Nereid, and the lack of any other substantial moons at all, because in this organization, Triton would disrupt the orbits or indeed collide with any of the original moons that happen to be in and around its vicinity. And so that would probably account for why it is the only large one left. And there are also some evidence that it may have suffered a number of collisions. Now, that's a little bit tentative at the moment, but it relates again to this idea of interior heat. We think that there is this liquid layer beneath the ice shell, and that heat is rising out of the core from the rocky and metal center of this moon. But it shouldn't really be there. If this was an isolated body away from everything else, having had a straightforward existence, a small body of this mass with the heat conductivity that the materials have would have ditched all its internal core heat to space. There would be a little bit left from the very small amount of residual radioactivity, but that decays over time, and therefore by now, after 4.6 billion years, there wouldn't be very much of that left. So why is it still warm? Well, something reheated it. This could have been a collision. It could have been the tidal squeezing during its capture phase. When it originated and came into the gravitational well of Neptune, it would have been in a highly elliptical orbit, and that has been gradually circularized, probably by a bit of friction with material in orbit around Neptune, sort of going the wrong way against a gaseous envelope, has gradually circularized the orbit. And of course, also it's ended up in tidal lock now, but it would not have been in tidal lock to begin with. So the tidal heating through squeezing and stretching may have contributed a significant amount of heat, and it may have got a pulse of heat from one or more impacts with either an original moon or smaller moonlets that it collided with. And something strange must have happened, because to get captured by a planet is not an easy thing. A body that comes near to a planet but does not crash into it will pick up speed as it enters the gravity well and just fly by and exit the other side, slowing down, pulled back towards the planet. But it'll leave with approximately the same amount of energy and momentum that it came in with. It might be going in a different direction, but unless it can dump that energy and momentum somehow, it's not going to be able to enter orbit. That can happen through a collision, but that's a pretty drastic explanation. It could happen through atmospheric drag, either with the main atmosphere, which is likely to lead to you either burning up or skipping off the surface, or perhaps just through passage through the thinner outer layers, which might slow you down and bring you into orbit. But such an orbit then would likely to be very close to the planet indeed. More likely is that it's an interaction between the incoming object and a third body, such as an existing moon. And the early ideas for this were that there was a collision, and that the proto-object, the precursor to Triton today, collided with another moon in orbit around Neptune already, and then the two created a whole mass of debris and formed one larger object, plus lots of small bits that then either fell onto Neptune or onto what is now called Triton. But it could also be a very disruptive event. And if you disrupt the whole thing, then you're very likely that the material that you end up with is only that ended up going the right way round. It would be in a fairly normal moon-like orbit rather than in the retrograde orbit. So the collision idea doesn't make a lot of sense. What makes more sense is binary capture. Now, actually, we know from our studies of objects that we are finding in the Kuiper belt that a lot of them are binary or multiple systems. There are a lot of the Kuiper belt objects that have moons, some of which can be quite sizable, or they can indeed be sort of almost double dwarf planets, if you like. And so perhaps what happened here was that a binary Kuiper belt object approached Neptune, and when it does that, you get an exchange of energy. Inevitably, one of the objects is going to be nearer Neptune than the other. And from our understanding of tidal forces, the effect of that will be to pull the near one towards Neptune much more strongly than the further one is pulled, and to try and deflect it by more. And this can unbind the binary. You can actually get a situation where the difference in the gravitational pull on the two objects represents a greater potential energy than the potential energy of binding that's keeping the two together. And then the object becomes unbound. And what will happen then is one of them will end up slowing out of the path and ending up in orbit around Neptune, and the other one picks up a lot of kinetic energy and momentum and carries away all of that and all the angular momentum of their orbital coupling, and ends up being hurled away at much greater speed. And so this is probably the most likely method by which things get captured, is that they started as a binary pair, as in this artist's illustration that we have here. So it's quite possible, and some people have argued that indeed the binary pair might have been Triton and Pluto, and this might explain why Pluto's orbit intersects with that of Neptune, and maybe the two were somehow related in a more complex system, and that something happened and Triton ended up being captured and Pluto kicked out. Now, and the analysis of the orbital dynamics that's been done argues against that in some cases, but of course things can have changed since, so it's quite difficult to know, really. So only one spacecraft has been to this region of the solar system. We've had one flyby in 1989 by Voyager 2. It only imaged 40% of the surface of Triton, so 60% yet to look at, as it whizzed past at high speed. Took as many shots as it could, but it really wasn't near Triton for very long at all. And it took this one lovely parting shot of Triton backlit by the sun, showing just that thin crescent, and you can even see the little bit of atmosphere there around the planet. Well, I call it a planet, it's a moon really, but I think of it as being a very, very interesting world, and hopefully we will get to go back. There have been several ideas. There's been the Discovery class Triton mission, the New Frontiers class Triton Ocean World Surveyor, and Nautilus. And the picture that we have here is a hypothetical Triton hopper spacecraft that would be able to land on Triton and then hop from one location to another in order to get around. And these seem to be quite the rage for trying to get samples from more than one location. Of course, they're probably going to have to be nuclear powered, and I'm not sure that NASA's currently got any plutonium left from its series of outer solar system explorations. So what's going to happen in future with Triton? Well, we've got 3.6 billion years before its orbit decays. Again, it is orbiting through and against the flow of gas molecules around Neptune, so it's gradually losing energy and momentum and will spiral in, and in that time frame it will end up too close to Neptune, inside what's called the Roche limit, where the tidal gravity forces from Neptune will cause it to either get torn to pieces and form a new ring around Neptune. And we've got this lovely James Webb Space Telescope picture here of Neptune with its rings, and up at the top left there, that's Triton. Or if it manages to survive the gravity of Neptune, which seems doubtful, then it could enter Neptune's atmosphere and be consumed, and that would be very spectacular. But it's 3.6 billion years in the future, so all sorts of things could happen by then. So thanks very much for listening, and I've enjoyed presenting this once around Triton. I hope you liked it too.